This next question is from the multiple choice section. It says the derivative of function f is continuous on the closed interval from 0 to 4, and the values of f and f prime are given, and they're given in this table. It tells us that the integral from 0 to 4 under the derivative function is equal to 8. So that also means that the displacement from 0 to 4 is equal to 8. Okay? Then it asks us the value of f of 4. Okay, so to find the value of f of 4, what we need to do is we need to have some starting point and the integral, okay, or area. So we've been given the area here. So this is area given here. The area is 8. What we need is a starting position. And our starting position is going to be based on this value here. Remember, that's our starting position. So at x is 0, we know that y is 5. That's going to be our starting point. So we're going to start at 5, and then we're going to add in the area from 0 to 4, and that will give us, under the f prime graph, this will give us the displacement. And this is the expression that we were given at the beginning. So that's equal to 8. So if I want to work out f of 4, f of 4 is equal to 5 plus the displacement. And in this case, the displacement is 8, going from 0 to 4. So f of 4 then must be equal to 13. Okay, so the answer in this case would be E. This problem is also a multiple choice questions from the multiple choice section on the AP exam. It says the particle moves along a straight line for 6 seconds, so that's velocity in centimeters per second. So again, we're talking about velocity, and they give us the units, is modeled by the graph below. So this graph is, the y coordinate is going to be the velocity. And a time interval from 0 to 6. What is the total distance the particle travels? Okay, so we just have to make sure that we recognize that we're talking about distance. So distance is equal to the absolute value of the displacement. So what that means is all the negative areas must be accounted for as positive. So I have this area above here. I'm going to use a different color here. So this area above here, I'm just going to split this up a little bit to make it easier to calculate. So that area in there is going to be a 4 by 4 square. So I have 4. This area in here is going to be a 2 times 1 divided by 2. So that is an area of 1 unit. And then we also have areas below. In this case here, this area is going to be 0.5 but negative. And this area in here is going to be negative 1. Okay, so that's going to be negative 1.5. Now, in this case here, the displacement would be 4 plus 1 minus 0.5 minus 1. However, we're talking about distance. So the distance, if I want to calculate the distance, my distance is going to be equal to the area of 5 plus that area underneath the curve is going to be now negative 1.5, but we want the distance, so we're going to make that positive. So the distance traveled is going to be 6.5. In this case, it looks like it's in centimeters per second, so the units are centimeters. So the answer is D. So it's important to recognize also that the displacement in this case would have been this value of 3.5. Okay, but this represents displacement. Okay, maybe I'll do that in a different color here. This value here indicates the displacement and not the distance. Okay, so it's important to recognize when we're being asked for distance versus displacement.